So here we are in CyberChef, and now we will look at a malicious document. It's actually from an Iranian EBT attack, Advanced Persistent Threat. And this document, we will be extracting different malicious strings from this document and finding what exactly this malicious document is doing. And we'll do all of that by string extraction, string manipulation through CyberChef. So let's open first our file, and this is basically the interface of CyberChef. Just to explain it a little bit, here is our input data, and here's the output from all the manipulation that we want to do. There is so many different things we can use here. This is my favorite, but here you can have the different encryption and decryption, public key encryption, some utilities like differences, remove null bytes or remove any empty bytes, convert things to a table, sort, split, things like that. So many different things we can use here, some related to compression, some related to forensics, and so on. So there is so many different strings manipulation or data manipulation available by CyberChef. And as I told you that CyberChef can be downloaded on your system, better to use it from your virtual machine. You can download it in your system, open it to your browser, put the input file you want here, any input data. You can create multiple tabs as well and put different data and test all your recipe of changes that you want to do to that data, and the output will be all will be here. You can basically save the output back again on any file and use it for further investigation. So let's get started with our file. We click open file as input. We have here the Iranian EBT malicious document. This document is a zip file. It's actually a zip file, and the password of that zip file is infected, written like that. So you need to extract this file with password infected, and you will get this file. This is actually a document. If you, it should be renamed .doc, but we will not do that because we don't want to mistakenly open that document and actually execute it. So we will just keep it with .bin, and we'll open that file up here. As you see here, he doesn't show you the output. The reason for that is it might be too heavy in your browser. If we click on show all, he will tell us this could crash your browser. Use it at your own risk. We'll not click on it now, but we know that it's just binary data, and this binary data might include some strings that are useful, might include different things. So actually, I will click on show all. I was thinking about that. I'll click on show all to show you how it looks like, even it might crash my browser. And the reason for that, I want to show you that it looks like a binary data like this one. And if you go deeper, it's more binary data. But at some point, there might be some text along this binary data. You might be seeing some text already while we are scrolling. So some things like this, Windows user, some random text like that. We want to extract this text and see what exactly is written inside this document. If there's malicious code, if there's something, if there's a link URL, a command, a cmd command that we can understand, whatever we can find up here. So the first thing, we want to extract strings. CyberChef includes a command here called strings, and this helps you to extract all the strings from inside the binary. We put it up here, and it will extract any string with minimum 4 characters. And we can see here there's so many texts have been extracted. So many text was inside the document. We didn't see them when we were scanning the binary, but we also see a lot of kind of garbage, like text that doesn't have any meaning. There are a lot of them. We can decrease that by increasing the minimum length. So we want to have at least the text 10 characters. You can increase that, you can decrease that, it's up to you, but at least I think now it's a bit worse. Let's try again 10. Yeah, he had, I think, some error. Anyway, so here's the text, and you see now the garbage is still there, but it is longer, so it is less garbage or less wrong text are there. Are they actually text? No, they might be part of the code, random data, random binary, but somehow they look like a text for the strings command. They look like they have really some letters. So strings think it's text, but it's actually not a text, it's just random bytes. But here we can see some things that we can understand, like click here to see more, forum, command prompt, and we can start to read a little bit to see if there's anything we can find useful. We see here there was a form, inside there's a command button, probably some XML files, some information, some XML data. We scroll through and we see if there's anything interesting we can see. We see here pictures. We don't see a URL that we can access online. We don't see a link to a website, but we see just paths up here. Still nothing useful, some images and stuff. If we go a bit more, we start to see some things that are really interesting. We see here URL download to file, command one _ click. If you are familiar with Visual Basic, they have this type of naming, and as well the type of naming their methods. So we know that there is a command button one, that's a button that is there in the document in a form somehow, and the method that executes, or the code that's being executed when you click on that button, always will be with that name. Command button one, which is the name of the button, and underscore, and then the name of the action that had happened on that button. So on that button. So command button one _ click means that this is the code will be executed. This is the name of the function that will be executed when this button has been clicked. If you have a document like here, the document _ open means this is the code will be executed when this document is being opened, and stuff like that. Form one _ load means when the form is being loaded, and so on. This is mostly the Visual Basic type of language. They mostly have this way to represent a specific action on a specific item, or specific button, or specific object they have there. We see also download file. Document _ open means that this will be the code that happens when the document is being opened. A lot of malware, they put their code under document _ open because they make sure that it will run every single time. And here we see URL download to file again. We see PowerShell, PowerShell.exe, and then PowerShell.exe, and a full command up here. To make you understand what's exactly the parameters here, PowerShell.exe is a known application for executing PowerShell commands. It's a very known language, and we have talked about it already. Window hidden, so he wants basically to run PowerShell with a hidden window, so the victim doesn't see it, and he wants to -e is basically represents encoded command. So here is telling PowerShell to execute an encoded command. Encoded means it's not encrypted, but it's kind of between compressed or just changed form. So this command is basically encoded, and you can take it as an encryption, you can take it as means compressed, whatever it is in a different form, and we need to convert it to a normal text. And PowerShell, as a program, it can take commands directly by -C and the command, whatever the code you want to execute. But if this code has lots of characters that might mess up in your command line, you can encode that to be able to give it as a parameter to PowerShell to make it easier to process. And the name of the encoded algorithm is base64. So just to give you some information about base64, it's a kind of binary to text encoding schema that tries to present some binary data, whatever is any random data, into a text like that you see up here. It is a way to represent some data in a different form, make it easier to digest, easier to give it as a parameter in the CMD or the command prompt, easier to communicate it along the way. It's just a simple text with all letters, some numbers, and maximum these two equals. To detect base64 type of encoding, you can see this type of blob of letters that doesn't have space between them, and lots of capital and small, and mostly it ends up either with one equal or double equals, mostly, but not all the time. If you take that one, you can take that PowerShell code, open a new tab up here, put that PowerShell code, and now this base64 code, and now we want to see what this code actually is. We can decode it with the CyberChef by using base64 and using from base64. So this is basically this recipe decodes that base64 and convert it into a text. If you put it up here, sorry, low storage, we can see that he converted them into some text. PowerShell.exe hidden, a dash window hidden, but there's this dots in the middle, this null bytes. They call them null bytes, and it's kind of not easy to read. We can just go into remove null bytes up here, so we can remove all of these dots, and here we go. PowerShell hidden, and then execute a command. IEX new object. You don't need to understand all that code, but you need to see here there is a URL. Up here we can see it in the code, and we can see an exact IP. This is the attacker IP, and this is the attacker port that he's listening to receive commands from this malicious document. Now we have an IOC, now we have real information. We have this URL, and we can use it as an IOC to detect all the machines that have opened this document. So this is the first thing we can do, as well as we can continue reading more into the strings. We have found this PowerShell command with this base64 encoded data, and now we can scroll more, and we see there's even more PowerShell commands. We can see here dash window hidden that looks like the parameters for PowerShell, and then we have the start of the base64 up here, and we see it continues more and more and more and more until up here with the two equals. We can go and open another tab and do exactly the same. Run there from base64 and remove the null bytes, and we get into another additional code up here. We'll not go into understanding all that code because it's a bit more complex, but you can understand how the whole malware look like. We can take this data, for example, we see it's like hex data. We can take this data, go to another tab. My laptop started to be slow. We can put that data up here, stop all of this recipes, and then try to convert it to from hex. So we can take from hex up here and try to see. Well, it doesn't look like it worked very well. We might need to remove this 0x and these commas. That's easy to do. We can search for replace, find and replace. We put it up here before we convert everything to hex. We can close this one for now, and we can search for any 0x and replace them with none. We can do another one up here and remove the comma, replace it with nothing, and now we have just hexadecimal data without any commas, without any 0x. Now we can run this one and see it in hexadecimal. It still doesn't look like something we can understand. We can ignore that one and look at it if it's an assembly code, for example. We can put the assembly code up here wherever we want and look at it. And we can see here, it looks like, at the beginning it looks like a functional code and a functional assembly code, but then it gets a bit more broken. So actually this is like an assembly malicious code, a malicious assembly code, and I'm not going to the details of this one because it's very complex. But here we got an example of how this idea works, how we can use something like CyberChef to analyze documents and dive deeper into the documents, from looking at the strings, as we did in the first one on the malicious document, to find PowerShell commands to decode the PowerShell base64 data, and at the end understand what this data is doing, extracting IP, extracting information, and probably also extracting some assembly code from the malware. We can take that code later on an IDA-Pro or an OLE debugger. We can put it in OLE debugger and code analysis. That would be the way later, and we can actually analyze that code and understand what exactly it does. So we have with just basic static analysis with CyberChef, we were able to understand so much information about this malicious document. We were able to understand the PowerShell code that it does, extract the malicious IP, extract the link that it connects to, like this one, and able to extract real IOCs that we can provide to the company. We can actually take actionable steps out of this IOC to detect all the machines that try to connect to this IP, to isolate these machines, to eradicate the attack from all the machines that might have opened this malicious document and executed the microcode. So that's for this video, and we go into the next section of behavior analysis. See you in the next video. Bye bye.